Okay, here we go. This should be almost all review for you guys. Acute angles. Less than 90. So, and I'm going to put up here a new symbol for you guys. It's called theta. Theta is like basically like a variable. And for an acute angle, theta is anything that's greater than 0, but less than.
What did you say that was called?
Theta.
Theta.
It's just like calling it X or Y, but a lot of times for angles we call them theta. All right, so Morgenstern. What would an angle actually look like? Or an acute angle look like? Yeah, kind of close together, right? So basically, I like to say it almost looks like the book is closing. We're getting kind of close together. So we're going to keep defining these. Up next, Blake, what does the right angle look like?
It's 90 degrees.
Okay, so 90 degrees. What does it look like?
Just straight line.
Let's look at L. Okay. And what type of lines form right angles? Perpendicular lines. Yeah, so perpendicular line. Two lines are perpendicular, then they form right angles. Okay, so that's one of those properties in geometry that we learn about. All right, so for obtuse, Christina, what's an obtuse angle? Not Christina, Christina. More than 180? Less than 180? Like 85? So is 85 an obtuse angle? So between what two values? More than 90, but less than 180, yeah. Okay, so that again is going to have a range. So we have to be more than 90, but less than 180. Okay. Christina, what would that look like? Yeah, so it's like we're opening up our book, right? Shelby, talk to me about a straight angle. 180 degrees. Is that the only type of straight angle? Or is there another way to have that? Okay. What about 0 degrees?
Yeah.
Is 0 degrees the same thing as 180 degrees? Yeah, pretty much. So Amber, what would a straight angle look like? Straight line, yeah. So a lot of your straight angles, they make a line. There's a vertex in the middle. Okay, a lot of times we'll call these opposite rays because they go in opposite directions. Okay, so opposite rays form a straight angle. Courtney, explain to me what complementary angles are. Forget. Don't forget. All right, you're going to have to pay attention now from this point. Hey, Danny, what about you? Complementary angles. No, they're going to have the same vertex, but there's two angles involved. Okay, Cheyenne? Yeah, so we have two angles that add up to 90. So you kind of, basically we're gonna draw a right angle. And then I have a third ray somewhere in there. Does that make the two angles equal? No, so they are definitely not equal. And the way we would represent that is you're gonna have a single arc on the inside, and then another one would have two arcs. Okay. So just like with segments, you'd have like a single tick mark or two tick marks, right, to differentiate their sizes. Okay, we do the same thing with angles, only we use arcs instead of tick marks. So they add up to 90. Another way I could write this out is if I actually label these. A, B, C, and D. Another way to write that out is to say that the measure, that's what the little m means, the measure of angle VAC plus the measure of angle CAD is equal to 90. That means that they're complementary. And Morgan, talking about supplementary. You don't know what that is? Okay. Mason?
There are two angles that
They add up to 180. So it's just like complementary, only we're going to add up to 180. And you're going to hear those terms a lot, so it's really important that we get these two down. Complementary is 90, supplementary adds to 180. Now I want you to stop and think about that for a minute. If it adds up to 180 degrees, what shape did I just create?
Wait,
If I can add up to 180 degrees, what shape did I literally just create? We've already somewhat talked about this morning. Yeah, it's just a straight line. Not a straight line. And again, they're not going to be equal. All we do know is that they add up to 180. So the measure of angle BAC plus the measure of CAD equals 180 degrees. All right, any questions on those terms? That's pretty much what you guys had to do yesterday, right? Go online, find the terms, we should be good to go. Saves us a lot of time there. Now there were a couple more that I want to add on to that list. And again, this is something you guys should have researched last night. Adjacent angles. So Caitlin, what did you find out about adjacent angles?
I didn't have internet.
Okay. So Brittany, help her out. What did you find out about adjacent angles?
There are two angles that share a common side and common vertex.
Yes. Common side with a common vertex. So basically, they don't necessarily add up to anything. But that's what adjacent means. We're going to share a vertex. Let's highlight that for a minute here. So we're sharing a vertex. There's our shared vertex, and there's our shared side. So that's what adjacent angle is. All right, vertical angles. Vertical angles. Alexis, what did you find out for vertical angles?
I don't know.
Oh, I'm sorry. Yes. You didn't get a chance to look it up? All right, let's what did you find out for vertical angles?
I didn't get a chance to look at it.
Does anybody else find that? Kayla? Okay, no, tell me what that means.
They're opposite.
What do you mean by that? Okay, alright. Let's try to make sense of that. So I have two lines that are gonna intersect, right?
Yeah.
That's the general gist of it? Alright, so let's bring this back down here. One line, another line. Here's the gist. Basically, vertical angles are opposite of each other across the vertex. And not only that, but it's really important we get this down. Vertical angles are always congruent. And vertical angles are always congruent. In fact, what we're going to do here, let's model that for you. So again, notice that no matter how these lines intersect, what do you notice about those vertical angles?
They're the same.
Always going to be the same. And that's true on both sides. So these two are equal and these two are equal. By the way, what shape is this? An X. Anytime you guys see an X, immediately your red flag should pop up like, oh, vertical angles. Every time. Anytime you have anything that remotely looks like an X, you have vertical angles. It's one of those things for geometry that's really, really important to I guess, identify. It's one of those things that keep popping up over and over and over again throughout the entire course. So vertical angles are really important here. And then talking about linear pair. What does that actually mean? Come on for a minute. Linear pair.
Something about a line.
Something about a line. That's the linear part. Pair means what?
A group, so a pair of angles that make a line.
Pair of angles that make a line. That's it. Two adjacent angles that form a line. And we're done. Now with notes, but just with some background information. Okay, so go ahead and close your laptop. So you can use your laptop for it.
What was the definition for that again?
Two adjacent